So we have already learned how to add vectors geometrically. We have also learned how to resolve a vector into its two rectangular components and the composition of vectors. So with those we will now start with addition of vectors analytically. How to add vectors. Today we are going to study how to add analytic vectors analytically. So the headline is analytical addition. Analytical addition. Addition of vectors. Suppose we have two vectors, say A, which is say 10 meter 30 degree north of east, and B, oh okay, sorry, this is the problem, but we will do that after that. So, now suppose let us how to do add that to geometry. Let's suppose we have two vectors. So first of all, consider our reference axis as xy. Suppose this is our x-axis and this is our y-axis. So it's x-axis and y. Now suppose we have two vectors A and B. Let the vector A is this is a vector A and we have to add another vector with A. So in geometrically addition means you have to draw the tail of this another next vector on the head of the vector A. So suppose this is the vector B which we have added to vector A. The resultant will be, obviously the resultant will be the straight line joining the tail of the initial vector to the head of the final vector, which is, say, this is. So this is the geometrical addition of vectors, which we have already learned. Now we also know how to resolve the vectors. Now let's suppose the vector A makes an angle, say theta with x-axis, and vector B makes an angle phi with x-axis, and the resultant vector R makes an angle, say alpha with the x-axis. Now we can resolve vector into its rectangular components. Suppose let us take that is the rectangular components along x-axis and y-axis. So the x component of the vector A, draw perpendicular from the tip of the vector A to the on the x-axis. So this gives you the x component of A, this gives you the y component of A. I resolve this vector A into its two rectangular components. So its x component is denoted as AX and this is denoted as AY. So the vector A is AX plus AY. Now we resolve the vector b along x-axis and y-axis. So the x-axis is, and if we resolve, so it's a 5, right, smaller one. So we resolve, let's draw a perpendicular. It is bx and this is by. So the vector b is the resultant of bx plus by, where bx and by are the rectangular components of the vector b. Similarly, we can resolve the vector r also along x and y axis. So the resultant of the x component of the r, we draw this will, this length will be rx and this length will be equal to ry. So this, to resolve this r into x component, this will be rx and this will be ry. So rx, r is rx plus r. Now dx and this is parallel. So we can write this, if this is bx, this length will also be equal to bx. So we can write that ax, because these are parallel vectors and we know that the parallel vectors of same magnitudes are equal. So this line is parallel to this same magnitude. So this, if this is bx, this is also bx. Similarly, if this is ay, this will also be ay. So we can say that rx is ax plus bx and ry is equal to ay plus dy. Okay. Now we also know that the magnitude of the resultant is given by the square of their rectangular components. So the magnitude of r vector r, that is mod of r, will be given by rx square plus ry square and the root, and the direction of r is given by the division of ry by rx. So tan alpha, this is the angle alpha, so tan alpha will be given by, this is tan alpha is the ry by rx. So tan alpha will be given by ry by. So in this way, this is the resultant of the magnitude of the resultant and this is the direction. So this, in this way you can find, you add vectors analytically. So what you have to do in order to add vectors analytically, you, you resolve all the vectors to be added into its x and y components. The sum of all the x components will give you the x component of the resultant, and the sum of all the y components will give you the y component of the resultant. Use this formula, rx square plus ry square under root r, and divide ry by rx, you will get the direction of the resultant vector. So we will write this statement and solve the problem. In order to add vectors analytically, resolve vectors to be added. Into their x and y components. The sum of all the x components is the x component of the resultant and the sum of all the y components. Is the y component of the resultant. And to find the magnitudes, use the formula r square, r is square is equal to rx square plus ry square. To then the magnitudes is given by, okay, right here. Okay, you can rub this one. The magnitude is given by the magnitude of the resultant let's say R is given by mod of R is given by Rx square plus Ry square, and the direction is given by and the direction of the resultant with x-axis, and the direction is given by tan alpha, or say alpha is equal to tan inverse r by y or x, or alpha is equal to tan inverse r by y. So it means that now if you have a large number of vectors, say A, B, C, D, E, F, resolve all of them into the rectangular components. All of them will be, suppose we have vectors A, B, C, D, and we have to all add, so mathematically or say analytically resolve all of them into their x and y components. So the resultant of the x will be given by Ax plus Bx, Cx, Dx, and Ry will be given by Ay plus By, Cy plus Dy, and the square of these, using this formula, we will get the resultant of the sum of A, B, C, D, the magnitude of the sum of the vectors A, B, C, D, and the direction is given by R by Rx. So now solve one of the problem and see and compare it with this geometrical addition and analytical addition. Let's see. sides. For example, let us consider vector A, which is 10 meter 30 degree north of east, and vector B as 10 meter 60 degree north of east. So if you draw it geometrically, this will be, so first of all we are, but in geometrically, so first of all we have to, this is our, say, east, this is our north, so it is east and this one is north. So first convert it into suitable scale. Let 2 meter is equal to 1 centimeter. It means 5 centimeter line will represent this vector. So first of all we have to take 30 degree north of east. So the 30 degree north of east is okay. 30 degree is here. So this is 30 degree. And we have to draw 5 inches line. I am not drawing centimeter because centimeter on the board will be very small. I am taking it into inches. So this is a vector A making 30 degree with east along the north side, 30 degree north of east. So this represents vector A. Now the vector B, which is 60 degree north of east. So from here we will draw vector B. From the east direction along this is the east direction. And we have to draw 60 degree from here from east towards north. So 60 degree will be, yes, this is 60. So 60 degree means you have to draw 5 inches line here. It is like 10 meter. So this means this vector represents B and this arrow represents A. Now the resultant is given by approximately 9.4. So it's the magnitude of R comes out to be 9.4 into 2, that is 18.8 meter, and the direction is here 46 degree, 46 or 47. So it is alpha is 46 degree north of east. This is our east direction. So geometrically we get this result. Now we will solve it analytically. Analytically means we have to resolve this vector along its x and y components. and this also along x and y components. So suppose this is our x-axis and this our y-axis. So the x component of A will be Ax will be equal to A cos 30. Because if this is 30 degree, it's the component of this along x, there will be Ax 30 degree, A cos 30, and this will be A sin 30. So its Ax is this much and Ay is A sin 30. Now Bx will be B cos 60 degree because it makes 60 degree. Yes. And By B sin 60. So now we know that cos 30 is 1 by 2 and the value of A is 10. So it's 10 by 2, that is equal to 5. Its magnitude comes out to be 5. And cos 6, sorry. It is root 3 by 2. Cos 30 is root 3 by 2. Root 3 by 2 times 10 means 5 root 3. So this comes out to be 5 root 3. And cos 60 is 1 by 2. So B is 10 and 1 by 2, that is equal to this 5. And Ay is A sin 30. Sin 30 is 1 by 2 and A is 10. So 10 by 2 is 5. And sin 60 is root 3 by 2. So it is 10. This comes out to be 5. Now Rx is Ax plus Bx, which means 5 plus 5 root 3. And Ry is Ay plus By, 5 plus 5 root 3. Now, so I am removing this. I think this is to make space for my calculation. So, R is magnitude of R is given by Rx square plus Ry square is the square of this and square of this. The square of this means 5 plus 5 root 3 whole square plus again 5 plus 5 root 3 whole square. Or we can simply write this, both of them are same. So you can write 2 times 5 plus 5 root 3. So by chance that both of them became equal. So it's 5. Square of this means 25. A square plus B square 75 plus 2AB means 50 root 3. So 100, it's 200 plus 15 to 2, 100 root 3. So it is 200. Root 3 is 1.732. If you multiply it by 100, this will be 173 point. So this comes out to be 373.2. Take the square root of this. This comes out to be the square root of this comes out to be 19.31. And the direction is given by tan alpha is Ry by Rx. both the values of Ry and Rx are same. So that comes out to be 1. And tan alpha means alpha is 45. Tan alpha 1 means. So you have found that the result of the analytical calculation gives you the magnitude 19.31 and the angle 45 degree making with the x-axis. And here geometrically we found out to be 18.8. This is some error, but this is geometrical, error may erupt in geometrical measurement, and this is not 45 degree as. So this is accurate result, and this one is just to give you an idea of how the vectors add geometrically, how vectors can be represented geometrically. So up to now we have solved addition of vectors geometrically as well as analytically. You can do your homework by doing all the addition of vector. First you try to solve by geometrical method and then by analytical method. In the next class we will study parallelogram of laws and unit vectors. Okay, for today this much is enough.